In problem 26, we're asked to look at each of the given quadratic equations and determine the number and type of solutions to each one using our graphing calculator. So let's start by inputting y1 as the left-hand side. This is for part A, and y2 as the right-hand side. So I'm going to go to y equals and enter x squared minus 10x plus 25. And I'm going to graph this on just a standard window, zoom 6, and see what I got here. So that looks pretty good, and it looks like I'm intersecting the x-axis here just at 5. So let's verify that by putting 0 as my y2 and then checking the intersection. See where that lines up. Yep, looks like we're right at the bottom. So I'm going to count over 5 here, draw myself a graph, label the horizontal intercept as 5, 0. There's only one in this case. Because the parabola just touches the graph, the x-axis here, we only have one real solution, and that real solution is x equals 5. We can also say this is one repeated solution because we technically have two solutions to every quadratic equation, but if the solutions are the same, we don't often list them twice. All right, part B, we have another equation here, so let's go into our y equals, clear out the first equation, and enter negative 2x squared plus 8x minus 3. Again, we're going to graph on just a standard window and see what we get. Looks like we've got some solutions there. I'm going to try to reflect my graph here, there, something like that. And let's run second calc number 5. We're going to find our horizontal intercepts. So we have one horizontal intercept at negative 0.42, comma 0. And that one is, actually, I'm sorry, that is not negative. That is a positive 0.42. It is right here. And let's find the second one, second calc, number 5. And I'm going to need to actually run that process. I have to be careful. I'm going to run it again because I've got to move my cursor. If I don't move my cursor, I'm going to get the same intercept that I just got for the first round. There we go. Now I can do it again. And I get 3.58, comma 0. And that's going to be this one right here. So there are two real solutions for this quadratic equation, and they are x1 equals 0.42 and x2 equals 3.58. So notice that the solutions to the quadratic equation set to 0 are the horizontal intercepts for the parabola. Those two go together. So let's check the last one. First, we're going to need to write it in standard form. The first two equations we had were already in standard form, so we didn't need to worry about that. So to write this equation in standard form, I'm going to add 5 to both sides and set the equation equal to 0. Then I'm going to go to my y equals. I'm going to clear out the first equation. Then I'm going to enter 3x squared minus 2x plus 5, and I'm going to hit graph. And this one does not cross the x-axis, so I'm going to just draw the general shape of my graph here, meaning there are no horizontal intercepts, or none. Number of real solutions in this case would be 0, because remember, for real solutions, we are looking to see where they cross the horizontal axis. The real solutions then are none. So it will be the case once in a while that you get a parabola that doesn't cross the x-axis. We'll find later on that it has what are called complex solutions, but there are no real solutions to this equation.